Welcome to my class. Good evening. Okay, this the chapter 1, state of matter. Okay, this is the part 3. Part 3. This is not here. Part 1, part 2 I have already taken. So this is part 3. Okay. State of matters, chapter 1. Okay, look at this solution formation. Look at the picture. Look, this is a like solid substance. Something is solid, solute. This is and solvent, and solute plus solvent form solution. So what is solute? Solute, when I add this solute in a solvent, this in water, like this water, and stir, this solid dissolves. And solvent in a solvent, this solid will dissolve. And solid and solute and solvent will form a solution. So solute, this thing, solute is a substance that dissolves in a solvent. Solute is a substance that dissolves in a solvent. Okay, solvent is the liquid that a solid dissolves in. The liquid that a solid dissolves in. And solution is a mixture, the mixture formed when a solid dissolves in a solvent. So solute is a substance that dissolves in a solvent. Okay, the liquid that solute, the liquid that a solid dissolves in. And solution, the mixture formed when a solid dissolves in a solvent. Okay, now I am giving these things example. You say it. This thing, okay, here some things. Which things have I used? Okay, like this is a like this is a sugar, sugar color is rare, yellow color. Okay, no problem. This my sugar color is yellow, and I take this one not to be clear. And this is a water here. Okay. Now also it dissolve in water. So this the okay, you will say which thing is A. What is A here? If you add these things, A solute, yes. If you add this one here, this thing, and stir by glass rod, you find the clear things. Okay, A is solute. Okay, good. A solute, and this one. This one is solvent, and this one is solution. So what is the definition of solute? Solution, and solvent. So what is the definition of solute?
The substance that dissolves in a solvent.
That dissolves in a solvent. They become dissolved in a solvent. The substance that dissolves in a solvent. Okay, now the solvent. The liquid that
dissolves in solute.
The dissolves solute in, and solution. Solution, the mixture formed when a solid dissolves in a solvent. The mixture formed when a solid dissolves in a solvent. Okay, now when you make a solution, the attractive forces between the particle in the solute are being broken. The attractive forces between the particles in the solid substance are being broken. At the same time, new attractive forces are being formed between the solvent particles and solid particles. Whether particular solid is soluble in any solvent depend on whether the new attractive forces are strong enough to overcome the old ones. So when a substance will dissolve, when the attraction force will overcome the old ones, there is a attraction force in a solute before adding a solvent. When this attractive force between the particle in a solute, what happened during the solution? During the solution formation, the attractive force between the particle in the solute are being broken, and at the same time new attractive forces are being formed between the solvent particles and solute particles. When new attractive force overcome the old ones attractive force, then solution form. Then solution is formed. Solid is soluble. Then solid will be soluble. If not overcome the new strong attractive force, the old ones, the solution will be it will be insoluble. Solution will be insoluble and soluble. Have you understood when soluble and insoluble? Okay, solvent. Okay, these things already taught. The solvent, the liquid in which a solid dissolve. Solvent, like in a seawater, the water is solvent. The water in seawater, in a seawater, the water is solvent. And solute, the substance which dissolves in a liquid to form solution. The substance dissolves in a liquid to form solution in the solute. So in a seawater, salt is the solute. Okay, solution, the mixture formed when a solute is dissolved in a solvent. The seawater is solution. Now the new terms, new term, saturated solution. Okay, I will this a saturated solution with maximum concentration of solute dissolved in the solvent and seawater in the Dead Sea. Okay, I will explain this one later. Wait, soluble. What is do you mean soluble? Describe a substance that will dissolve. Describe a substance that will dissolve. If substance dissolve, it is soluble. Soluble describe a substance that will dissolve, and insoluble describe a substance that won't dissolve. Okay, soluble. Salt is soluble in water, and insoluble describe a substance that won't dissolve. Sand is insoluble in water. Okay, now saturated solution term I will explain now. Yes, saturated solution. Saturated solution. Saturated solution, a solution that contain as much dissolved solid as possible at a particular temperature. A solution that contain as much dissolved solid as possible at a particular temperature. Look, this is a saturated solution. This is a saturated solution. A solution that contains as much dissolved solid as possible at a particular temperature. If the much amount of solute is possible to dissolve at a particular temperature, then that solution is called saturated solution. Like you take like you take 2 gram salt 2 gram salt. Here add 2 gram salt. 2 gram salt. Okay, 2 gram salt. Okay, I should give this salt color. What is salt color? Like I take the copper sulfate. Copper sulfate is color is this color. Yeah. Okay, take a attendance for Arya. Take attendance.
Okay, sir.
Okay, and I am not explaining now. I am writing a this one. Glass rod. Okay, I'm now taking, there is a 2 gram salt I am adding here. I should use this. Then clear solution is found. Clear solution is found. Clear solution is found in a water. Here is a water I add here. Add water and water and I add stir glass rod and stirring. After stirring I found clear solution. Then I add 2 gram. Then I add 3 gram and in a I add the solute again in a solvent and stirring. After stirring 3 gram I add the salt. Then again I found clear solution. Again I found clear solution. Again I add 4 gram. That means more 1 gram I add. 4 gram, that means this is 2 gram. 3 gram. 3 gram means 1 gram I add more. Then another 1 gram add, it become 4 gram. When I add 4 gram, again I stir and after stirring I found clear solution. Again I found clear solution. Now I add 5 gram 5 gram 5 gram 5 gram salt, that means more 1 gram I add. Again I found a clear solution. Again I found clear solution. Again I found clear solution. Again I found clear solution. Okay, so what happening when I add 6 gram 6 gram, that means more 1 gram add, more 1 gram add, more 1 gram add this 6 gram 6 gram, and again start stirring. After stirring I don't find the clear solution. I don't find a clear solution. I don't find clear solution. I found some solute is remaining undissolved. Some solute is remaining undissolved in the bottom. Here I don't find clear solution. In here it is the maximum. Here maximum solute can dissolve this solution. This solution can maximum solute can dissolve. The solution which can maximum solute dissolve, this solution is called saturated solution. Okay, have you understood? The solution which can dissolve maximum solute, this solution is called saturated solution. Here this is not, this above, this thing is saturated solution. These things can dissolve solute, maximum amount of solute, but in the bottom this is not saturated solution. This is saturated solution. Okay, have you understood what is saturated solution? Saturated solution a solution that contains as much dissolved solute. 9 minutes remaining. You will join again if finish using the same link. You will join again. Saturated solution, a solution that contains as much dissolved solute as possible at a particular temperature. It's called saturated solution. It can much solute can this above this the not this the bottom, this thing is not. This solution is saturated solution, and it can contain maximum amount of solute at a particular temperature. It can dissolve maximum amount of solute, this solvent, and this solution, and form a solution, and it is a saturated solution. Okay, now this term is solubility. Solubility is a at a particular temperature the amount of solute dissolved in a 100 gram of solvent is called solubility at that temperature of that solute. It is given the mass of solute, the amount of solute which must dissolve in a 100 gram of solvent and form a saturated solution at a particular temperature. This is called solubility. This definition is given in your book. I said what is the amount of solute dissolved in 100 gram of solvent to form saturated solution at a particular temperature is called solubility of that solute at that temperature. Okay, now I am going to explain these things. In a 100 gram of solvent, you take 100 gram of solvent, 100 gram of solvent, take water, 100 gram of water, take water. Okay, in 100 gram of water, here solvent. Okay, maximum amount of solute required to form a saturated solution. To form a saturated solution, Like this is a 100 gram of solvent. Solvent here is a water, and from in sodium chloride. Like sodium chloride is required 36 gram. 36 gram sodium chloride is required. 36 gram sodium chloride is required to form a saturated solution in 100 gram of water. So solubility of sodium chloride is 36 gram. Okay, this is a 100 gram of solvent. In a 100 gram of solvent. Okay, solubility. Have you understood what is solubility? Solubility is the okay, say someone definition. What will be definition solubility? Say someone definition. What will be definition of solubility? Say someone definition. What will be definition of solubility? At a particular temperature, the amount of solute required in 100 gram of solvent to form saturated solution is called solubility of that solute of that temperature. Okay, have you understood what is solubility? At a particular temperature, the amount of solute required in 100 gram of solvent to form saturated solution is called solubility of that solute of that temperature. Okay, in a 100 gram of solvent, how much solute is required to form a saturated solution is called solubility of that solute of that temperature. You must use at a particular temperature, because if you use temperature increases, decreases, solubility changes. So temperature, solubility is dependent on temperature. If you increase temperature, solubility changes, solubility increases. So you must use temperature at a particular temperature. You must to say, you have to say particular temperature. Okay, different substances have different solubilities. Like I said, water sodium chloride solubility is 36 gram. Like potassium nitrate solubility, for example, I don't know these things, 40 gram. Like copper sulfate solubility is 60 gram. So different substances have different solubilities. Solubility can be expressed in gram per 100 gram of solvent. Solubility can be expressed in gram per 100 gram of solvent. Okay, solubility expressed in gram. We will express solubility in unit. We will use gram, not kg, not meter, anything. We will use a gram, not pound. Solubility can be expressed in gram per 100 gram of solvent. Solubility of solute is affected by temperature. As temperature increases, solute become more soluble. Solubility of gases is affected by temperature and pressure. As pressure increases, gas become more soluble. As temperature increases, gas become less soluble in general. Okay, investigating solubility of a solid in water. Okay, now we'll investigate solubility of a solid in a water. Dear student, you will join 2 minutes remaining. You will join here same link. After 2 minutes, less than 2 minutes remaining, you join using same link. Okay, investigating solubility of a solid at a particular temperature. Oh, where is this? Okay, this procedure we can use to measure the solubility of potassium nitrate in water at 40 degrees Celsius. So temperature is here is a particular temperature. It remains same 40 degrees Celsius is S flow. And at first step you will weigh an evaporating basin. At first you weigh an evaporating basin. Like you take okay, like what is the investigation name? Investigate solubility. Okay, experiment name. Okay, I should use orange color. What is the investigation? Investigating the solubility of a solid at a particular temperature. Okay, here particular temperature is 40 degree. And solid name, what is solid? Solid key. What is the name solid here? Here temperature is, what is temperature? Already you have been informed about temperature. What is temperature? I have said temperature and solid.
40 degrees Celsius.
Yes, 40 degrees Celsius. And solid is potassium nitrate. Here 40 degrees Celsius. Okay, 40 degree Celsius. Potassium nitrate. Okay, this temperature is 40 degrees Celsius. Okay, these things. So at first what will it do? You will weigh a evaporating basin. This is the evaporating basin. Okay, evaporating basin. Okay, here I'll take my solute, this evaporating basin. At first you will take this evaporating basin a digital balance. Okay, this digital balance. Okay, here give reading. You take this weighing evaporating basin here and take then reading this reading takes like it is like 5 gram. Okay, the reading in the digital balance show 5 gram. Okay, this the evaporating reading is 5 gram like this. And second step is क्या फोन दिया second Sherina is okay. Second step, heat a boiling tube of a water to just above 40 degree Celsius. Heat a boiling tube of water to just above 40 degrees Celsius. Okay, boiling tube. Second step is here. Okay, this is the boiling tube. That what is this? This one is boiling tube. This one, we take the solute in a boiling tube. This one, boiling tube. Okay, boiling tube. This one is boiling tube. This one is boiling tube. Okay, boiling tube. It's not drawing is not exactly. Can you please send the PDF? Please turn chemistry on class again. Okay, this is the water. This is the boiling tube. This one is a beaker like. Okay, step 1 to 3. You take the here. Step 1 and 2 3 1 2 3 1 2 3. What is this? You take at first you weigh evaporating basin. You take weight of evaporating basin, weigh and evaporating basin, and heat boiling tube of water just above 40 degree. Add potassium nitrate to the water in boiling tube and stir rapidly until no more of it will dissolve. There is undissolved solid left over. Okay, so what is things at first step is it is not it is here. Where the evaporating basin? Where is evaporating basin? So first step is look. Heat. Okay, I am showing this thing. I am drawing again here. Draw. You take this like here. Take beaker. Take beaker here. Okay, and here you take evaporating basin. Sorry, not evaporating basin. It is a boiling tube. Okay, boiling tube. Okay, here is a solid. Take solid. Okay, and here you added thermometer. I should give different color. Yellow color I give. Thermometer. Add thermometer. Is it here given or in the outside or be above by the where's thermometer given? Okay, thermometer is added in that boiling tube also. Okay, in the boiling tube thermometer added. Thermometer, boiling tube, thermometer, and okay, this things it is not. Boiling tube. Okay, this the reading, this is what is this, no, this thing is not showing visible. I am giving this is what is this is mark reading show, temperature reading show. This is a mercury scale. Mercury is it is, we know one solid is at a room temperature liquid. This is the mercury Hg. This is the one solid. This we know all solid are all metal are solid, but one exceptional metal, mercury. This is at room temperature is liquid. So its temperature, when temperature increases, its reading increases, it volume increases, so reading increases. When temperature decreases, mercury volume decreases, so reading decreases. So here mercury thermometer. So this is the boiling tube and this is the beaker. Here I'll give heat give temperature. I give this heat. Okay, I give temperature. I take this temperature more than 40 degree, above 40 degree. Okay, here is a potassium nitrate. This solid is, which one is potassium nitrate. Okay, these things is I am doing in step 1 2 3. Okay, heat at over 40 degree, over 40 degree. Okay, these things. Okay, this is water here. Yeah. Okay, I have said some apparatus name already, which things are needed for the solubility investigation. Solubility investigating solubility of a solid, which things are required already. This is the beaker, thermometer, boiling tube, and also here evaporating basin. Okay, so step 1 to 3 done. And now I'll do this investigation. Step 4. Here solid dissolved, maybe this solid not excess potassium nitrate, temperature slightly over 40 degrees Celsius, and here solid dissolved. Excess solid will take, because saturated solution will form when excess dissolve. After dissolving, when excess solid remain, then saturated solution form. So here excess solution potassium nitrate remains, so solution is formed, saturated solution form. Next, cool exactly 40 degree. Now cool exactly 40 degree. Cool now 40 degree done. Okay, now step 4, allow the solution to cool to exactly 40 degree. Our temperature is 40 degree, so you should cool, allow to solution to cool to become 40 degree. Okay, here is a cooling sum to decrease temperature, step 4. Okay, now step 5. Step 5, pour off some the solution. This is the saturated solution. Okay, this what is happened? Pour off some saturated solution into the evaporating basin. It is important that you only pour off solution, no solid. If you it is important, you will only pour off. It is, what is spelling pour off solution, no solid. You don't have to pour off all the solution. Okay, you pour off some solution, but not where you pour off some solution, not solid. some solution in a evaporating basin. Step 5. Okay, evaporating basin. In step 5, you pour off some in the evaporating basin. Pour off some এটা কেমনে, এটা দিলে তো সব পড়ে যাবে। তারা কেমনে okay, here solution is pure of, not some solution pour off, saturated solution, but not solute, solute will take here, remain in that step. Okay, this is the step 5. And step 6 is weigh the evaporating basin and contents. Now you weigh the evaporating basin with the liquid, this contents. Look here, step 5. This is become like 58 gram. What is this become? Now this is the 58 gram. 58 gram evaporating basin with contents, with solution. Okay, and then you give the water heat to become stem. Now you give heat to become the solution contains some water to become steam and evaporate this thing. And step 7, in step 7, heat the evaporating basin and contents gently to evaporate off all the water. When it look as if all water has evaporated, disappear, weigh the evaporating basin and contents. Step 8. So you evaporate, heat the solution with contents. So water will start evaporating. After disappearing, you take weigh of evaporating basin with contents solid. Then it is found 38 gram. Okay, at the beginning they have found mass of evaporating basin is 55.72 gram. At the beginning, I told this beginning here there was what is the was at the beginning evaporating basin weight was I should draw everything. No, I show here. No, at the beginning here it was what is the thing? 25.78. 25.78. 25.78 gram. Then here is again. Now I type here. It's not possible to draw. and here is evaporating basin and solution is 58, and evaporating basin and solid is 38. So evaporating mass of evaporating basin is 25.78, mass of evaporating basin plus solution is 58, mass of evaporating basin and dry crystal solid is 38. So what is the mass of crystal? What will be mass of crystal? Okay, so I showing this what is this here? Mass of evaporating basin is, what is mass of evaporating basin? Mass of evaporating basin. What is basin? Mass of evaporating basin is, what is mass? 25.78 na kita. What is mass? 25. Hello student, what is the mass of evaporating basin? No. 25.78. 778 gram. Okay, mass of evaporating basin plus solution. Mass of evaporating basin plus solution before evaporating, what is 58 gram, and mass of evaporating basin plus dry crystal what is this dry crystal? $38. 38 gram. Look at here given okay, to find solubility in gram 100 gram per 100 gram of solvent, need mass of solute and mass of solvent is required. To find the solubility, which things are required? Required mass of solute and mass of solvent is required to find solubility. So how can I find I can find this mass of solute? How can I find the mass of solute? Okay, how can I find mass of solute? Dry crystal. From how? Hello student, are you listening? At first I need mass of solute, dry crystal mass I need. So how can I find mass of dry crystal? Dry crystal. What can I do? Dry crystal. What will I do? Here is a mass of evaporating basin and dry crystal. What can this is the mass of evaporating basin? So what can I do? From these two information I can do something. I can find mass of dry crystal. What can I do?
38 minus 25.7.
Yes. Here contain mass of evaporating basin and dry crystal. I will deduct mass of evaporating basin. So it will remain dry crystal mass will remain. So I will deduct 38 minus 38 gram minus, okay, here I don't need to write 38 minus 25.78 gram. So what is the remaining? Calculator. 38 minus 25.7. Huh?
12.22.
12.22 gram. Okay, so I have found mass of crystal, that means mass of solute found. Okay, I need mass of solvent now. Mass of solvent. How can I find mass of solvent? Okay, here contain mass of evaporating basin plus solvent plus solute. Here contain mass of evaporating basin and solute. Here contain three things. Evaporating basin, these things. Evaporating basin, solution means solvent mass, solute mass. Here is a mass evaporating basin and solute. So what can I do? Here is three things in the above.
Solution minus solute.
Which things? Here is a basin, basin plus solution means solute. Solute, that means dry crystal. Solute, dry crystal here. Solute and solvent. Okay, solvent. In the here in the below these things mass is this 58 means these three things, basin plus solute plus solvent, mass is 58. Here these things, this mass this mass is basin mass plus solute. So how can I find mass of solvent? I need mass of solvent. So what can I do?
Solution minus solute.
So here I which things will do? This value. Which value to which value I deduct? Huh? Basin solute solvent minus basin plus solute. So I'll minus this 58 minus 38, then remain solvent. Okay, have you understood? এটা কি করছে এরকম আমরা পরে দেখি কি কি করছে. Okay, the mass of solvent is 58 minus 38. 20.
Yes, sir.
তারা কি বইয়ে কি এরকম করছে? দেখি আমরা কি করছে তার বইয়ে. Yes, they have done this way. Okay, they do these things this way. So now I can put this value here. I can put this value solubility here. So I found two parameter. So I can find the solubility in gram. So I can write solubility here. solubility equal to solubility which unit? Gram per 100 gram, gram per 100 gram. Okay, mass of solute is, my mass of solute is what? 12.22, 12.22, and this one is 20. Mass of solvent is 20, and multiply 100. So what is the solubility?
61.1.
61.1.
1.
Okay, so we have found the solubility. Okay, the solubility of potassium nitrate at 40 degrees Celsius is therefore 61.4 gram per 100 gram of water. Okay, so we have found solubility. Okay, thank you for joining today's class. I'll give you